Today we are going to talk about an object that constantly pops up in quantum mechanics and it's available in a bunch of derivations on the subject. It's going to confuse you if you haven't seen it before. So we are going to break it down in a pretty simple manner here. And the object is the inner product of the momentum eigenstate with the position eigenstate. So yeah, let's get started.
What is this? And to really understand what this exactly is, we're going to have to look at the Fourier transform of a wave function in position and momentum. So we have psi of x equals the integral of dp psi of b e to the power of I bx. And the interval is negative infinity to plus infinity. Yeah. And the reverse Fourier transform for this would be psi of b equals, let me put some space there, psi of b equals integral minus infinity to plus infinity dx psi of x e to the power minus I bx. Now, some things you need to understand before proceeding further. Psi of x really is just the position representation of the wave function psi. And similarly, psi of b is the momentum representation of the wave function ket. Now, here's what we're going to do. So we're going to take psi of x equals x psi, right? And we're going to use the property of completeness. We're going to say that x psi, we're going to insert something called the identity, which when you multiply with it, it just gives back the same thing. So these two, they are equal. So we say x b p psi, and this will be a continuous integral. So what I used here is integral over dp p plus identity. Right. Now we have this right here popping here again. So we say this is nothing but this right here. Right? So we say psi of p x p dp. And of course this will be minus infinity plus infinity interval. Right? Now we have this reserved right over here. Now recall that the Fourier transform of the position is given by this right here, this thing. So if we compare the two side by side, we have integral minus infinity to plus infinity psi p e to the power I px dp. And now if we compare the both of these, clearly we get the result by direct comparison. So we say x p equals e to the I px, and that is our answer. Now for the reverse of this, so if you want to find px, we can just say psi of p equals p psi, and we insert dx, the x momentum, x continuous states. So with that, let's move the plus infinity, say here dx psi of x and px. And by comparing this to this over here, we can simply say that px e to the power minus px.
And that's it. Thank you for watching.